All right, so our last example for section 1.5, and actually last example for our chapter, we're going to look at one more controlled experiment. So a study reported in the New England Journal of Medicine tested two medicines for Crohn's disease. Injections of infliximab, which is going to be referred to as Inflix for short, and oral azathioprine, which is going to be referred to as Azath for short. The participants were randomized into three groups. All groups received an injection and a pill. Some were placebos. One group received Inflix injections with placebo pills. One received Azath pills with placebo injections, and one group received both injections and pills. A good outcome was defined as the disease being in remission after 26 weeks. The accompanying table shows the summary of data that this study yielded. Right, so we're comparing these two different medications. Some groups only got one of the medications, whether it was the injection or the pill, and then one group of the three groups got a combination of both. Right, so for each of these different three groups, our combination, our Inflix, and our Azath, we're given numbers. Right, and then going across, we have our totals of people in remission, not in remission. Remember that this is from a previous section called a two-way table. All right, compare the percentages in remission for these three treatments. Which treatment was the most effective and which was the least effective in the sample? Remember, when we're thinking about percentages, right, percent is always going to be our part divided by our whole. So that's what we're going to use to find these three. All right, so combination. Right, we had 96 people in remission divided by 169. That gives us 0.5680, which is 56.8%. Right, sliding our decimal point 2 places to the right. Inflix alone, we had 75 out of 169. Right, this is going to give us 0.4438 or 44.4%. Azath alone, we had 51 divided by 170. That's going to give us 0.30, which is exactly 30%. Right, so in order to compare these groups, although our groups were similar sized, remember that we want to make comparisons of either rates or percentages. So we found percentages for all of these groups. All right, then looking at this, our combination is going to be the most effective, right? Because that is our largest percent, and our Azath alone is going to be the least effective. So then for B, can we conclude that the combination treatment causes a better outcome? Why or why not? And we are going to say yes. We see this word causes here. Remember that causes and causality, cause and effect, can be determined by a controlled experiment, right? Causality can be shown by a controlled experiment. Right? In a controlled experiment, we want to make sure we're thinking about and keeping in mind our four different key features. Right? So our four different key features, we have a reasonable sample size. Not as large as our previous example, but still probably large enough. It is randomized. It is placebo. Right? We're using a placebo that's controlled, which means that it is at least a blind experiment. Right? The participants don't know if they're getting a placebo. Since they're all getting two things, they're each getting an injection and a pill. They don't know which ones, right? So it is blind. And then our last and final factor Do we know if it's double blind? Not necessarily, but we can assume that it is at least a blind experiment. Right, so we've got a lot of our features of a good controlled experiment here, and as we're thinking about these, I apologize, I did not move my paper down as I was going through the last part of this example, so I'll leave that up there for just a minute as you're taking a look. Again, when we're thinking about causality and causation, right, it can only be established by controlled experiments. And this last example that we have here shows, again, at least 3 of the factors of a well-designed controlled experiment. Right? So as we're thinking about this, the idea of causality, causation is going to show up multiple times throughout the rest of the semester. But in the meantime, if we're asked about whether or not something causes something else, remember that it can only come from a controlled experiment, not an anecdote or an observational study.